Hey guys, we're looking at the Module 5 activity for the day. So this is called a special case. Let's just start working. Question number 1 says, suppose the amount of water in a pool decreases at a constant rate of 11 gallons per minute. So that's my crock and it's decreasing. So my crock is actually going to be negative 11 and the units on that are gallons per minute. And then at 0 minutes, there are 3,400 gallons of water in the pool. So that is telling me about my reference point. So it says determine the amount of water in the pool 27.4 minutes after the water began draining. You know me, I like me some tables, so I'm going to do this. So at 27.4 minutes, my change in input is actually also just going to be 27.4 because it would be 27.4 minus 0. I'm going to multiply that by my crock, so negative 11 times 27.4. I'm going to get negative 301.4 gallons. So in 27.4 minutes, we lose 301.4 gallons. So 3,400 minus the 301.4, I'm actually going to get 3,098.6. So that is my final answer. And by the way, it's gallons. If I'm going to write my formula, so I would say A equals negative 11. I'll use my original reference point, so T minus 0 plus 3,400. Question number 2 says, suppose you borrowed $8,000 from your parents to buy a used car. They didn't charge you any interest. Ooh, nice. But they require that you make a payment of $250 each month. A represents the amount of money you owe in dollars M months after making the payments. So the crock is actually going to be a negative $250 per month because the amount you owe is going to go down, right, as the months increase. And the reference point is going to be 0. After making 0 months of payments, you owe 8,000. And so then when I go to write my function, it's going to be something similar to the one above, like this. Question 3 says, suppose you're given a constant rate of change of 11.8. Reference point there, let A be the input and Y is the output. So Y equals just 11.8 times A minus 0 plus 18.3. Question number 4, suppose you're given a constant rate of negative 4.1 and this reference point, B is the input, P is the output. So again, I'm just going to take this, I'm going to write my formula like so. If we keep going, number 5 says a candle is 13 inches long before burning. Its length decreases at a constant rate of 0.9 inches per hour. So my crock is negative 0.9 inches per hour. This means that if we haven't burned it at all, it is 13 inches long. So if I want to find out the length after 2.1 hours of burning, again, I'm just going to do the same process. There's a point, 0.1. So 2.1 minus 0 is 2.1. So if we lose 0.9 inches per hour, we burned it for 2.1 hours. We have lost 1.89 inches. We started at 13, and so we are now at 11.11 inches long. All right, if I want to create a linear formula, L equals my crock. This probably feels repetitive. All right, like this. So then question 6 just says, for that info, fill in the blanks below. So I'm just going to go back to my answers from questions 1 through 5, and I'm going to fill this in. So it was A equals negative 11, T minus 0 plus 3,400. My crock on the second one was negative 250, 0, 8,000. We did A negative 250, M minus 0 plus 8,000. Sorry, didn't make my table big enough apparently. My third one is 11.8. And it was Y equals. Sorry, super exciting to listen to me write this all down. Negative 15, yeah. So P equals negative 4.1. Oops, not plus. And then finally, negative 0.9, 0, 13. And then here. All right, question 7 says, what do you notice that each problem has in common and what happens to each of the linear formulas? So if we take a look at these, one thing that I noticed, so most of those rates are negative, but not all. But the thing I really notice here is that all of my reference inputs are 0. So essentially all of these are my vertical intercepts. So that's one thing I noticed. And so then it says, what happens to each of the linear formulas? Well, one thing that I notice is that really like t minus 0 is just t, or t minus 0 up here is t, or m minus 0 is just m, a minus 0 is a, b minus 0 is b. So I don't really need to write minus 0, because in each of these cases, if I'm finding the change from 0, well, that value is just the same here. Like up here, like my change from 0 to 2.1 was still the same as the 2.1. That was the case over here. The change from 27.4 was just 27.4. So like in this case, the change in t was the same as t because we were changing from 0. And that's the same thing here. The change in t is the same as t because we're changing from 0. And so I would say, what do I say all have in common? The reference point is the vertical intercept. Now, a lot of times, so it's always going to be 0 comma something. A lot of times we use the letter B, so that's the letter B, to represent my vertical intercept. And in each of my cases, when my reference point is my vertical intercept, my formula can be simplified. And so if we take a look at that, really, this is my general form of a linear function. I'll use x's and y's. And so if I plug in 0b for my reference point, I'm going to get y equals croc x minus 0 plus b. But we just said that x minus 0 is just the same as x. And you guys never have written this way in your life. Instead, you probably, instead of writing croc, you always called it m. And so really, that leads us to y equals mx plus b. So that's pretty cool, actually. So y equals mx plus b, really we would call the special case. I know it's probably the way you were taught your whole life, but really it's a special case of a linear function, which happens, so if the reference point is the vertical intercept, right? So this form right here, I'll make a different color. This one right here, you have your croc and you give me any reference point, right? You give me any point like we've been doing for like the last 27, it feels like, activities, and I can write my formula. If my reference point is the vertical intercept, even if I start with this one, it's still going to simplify down. Or if I have my reference point, just like we had here, right? So here, this is always going to simplify, right? This one really I could have just written as L equals negative 0.9 t plus 13, right? It's always going to simplify to that y equals mx plus b. And so really it's kind of like we have two forms, but one is just a more simplified version of the other. So this one we call our like general form, and this one we call the special case, right? There's benefits and drawbacks to both. Obviously, y equals mx plus b is more simple, but you have to go find the vertical intercept. The other one is a little bit longer, but I'm really lazy, and so if all I have to do is write a formula like I did here, and let's say I didn't have the vertical intercept, I'm just going to use my general form because I can just use the point given and call it a day. So that's kind of really what Module 5, the special case, is about, is this: when my reference point is the vertical intercept, my general form simplifies down to this y equals mx plus b form that, again, probably most of you grew up learning and loving.